Relax. Seriously, take a moment. Set your shoulders down. Grab a coffee, tea, or whatever helps you slow your thoughts just a little. Because this story isn't just about a mysterious death. It's about prediction, probability, human pattern recognition, and the uncomfortable question of whether knowing too much can get you killed. If you enjoy stories that blend science, mystery, and deep questions about reality itself, make sure to like this video, share it with someone who loves thinking a little too much, and leave a comment with your theory by the end. Now, let's begin. Humans are prediction machines. Your brain predicts when a ball will land. It predicts the next word in a sentence. It predicts danger before you consciously notice it. Science itself is built on prediction. We create models, test them, and trust them when they predict the future accurately. But what happens when a scientist predicts something much closer to home? What happens when the thing being predicted is their own death? In the early 2000s, a respected scientist, let's call him Dr. Adrian Keller, began sending a series of emails to colleagues, friends, and family. The messages were unsettling. They weren't emotional. They weren't dramatic. They were precise. Dr. Keller claimed that based on his research, the probability of his own death within the next 18 months had increased to an unacceptable level. Not metaphorically, statistically. This immediately raises a question. How could someone calculate their own death? To understand that, we need to understand what Dr. Keller studied. He wasn't a fortune teller. He wasn't involved in fringe science. He worked in systems analysis and risk modeling, the same mathematical frameworks used to predict industrial disasters, aviation failures, nuclear accidents, and large-scale system collapses. His job was to find hidden failure points, the moments where systems look stable right before they catastrophically fail. And over time, Keller began to believe he had identified one such system: himself. You see, Keller's research focused on what's called convergent risk, the idea that individual risks, small, manageable on their own, can align in ways that dramatically increase the probability of a rare event. Think about it like this. Smoking increases risk. Stress increases risk. Exposure to chemicals increases risk. Sleep deprivation increases risk. Individually, these risks don't guarantee anything, but stack enough of them together, and suddenly, outcomes that were once unlikely become disturbingly probable. Keller believed his work, specifically research tied to industrial safety failures, had placed him under unusual pressure: professional stress, legal threats, political attention, long hours, constant travel, and something else. According to his emails, Keller believed he had unknowingly crossed into territory that powerful institutions did not want analyzed too closely. Here's where the story becomes uncomfortable. Keller had recently completed a paper examining how certain industrial accidents shared statistical fingerprints not consistent with randomness or negligence. In simple terms, he argued that some disasters labeled as accidents followed patterns more consistent with deliberate suppression of early warning signals. Signals that had been mathematically visible, ignored, buried. His colleagues initially dismissed his concern. Correlation doesn't imply causation. Outliers happen. Models aren't reality. All true, but Keller wasn't claiming certainty. He was claiming probability. And probability doesn't need certainty to be dangerous. In one email, he wrote something chilling. If my models are correct, then my personal risk profile has shifted, not because of a single threat, but because multiple low-level threats have aligned. This brings us to a crucial Vsauce-style question.
Can you predict a unique event? After all, probability usually applies to groups, not individuals. We say people who do X have Y risk, but Keller flipped that. He treated himself as a system. Inputs, stressors, feedback loops. And his conclusion was clear. Something was going to happen. About 6 months after those emails, Keller was found dead. The official cause, an accident. He had fallen from a stairwell in his apartment building. No signs of struggle, no suicide note, no witnesses. Case closed. Except, not really. Because here's the strange part. Several of Keller's emails predicted not just death, but ambiguity. He wrote that if something happened to him, it would likely be classified as misadventure or coincidence. Why? Because systems, especially institutional ones, prefer simple explanations, and because complex causes are uncomfortable. This leads to an unsettling idea. What if Keller didn't predict how he would die, but predicted the conditions that would make his death unremarkable? This isn't about prophecy, it's about statistics. Most people don't die in spectacular, obvious ways. They die quietly, accidentally, in ways that fit expectations. And that's what makes pattern recognition so difficult. Now, let's be clear. There is no definitive evidence that Keller was murdered, but there is also no definitive evidence that he wasn't, which puts us in a strange epistemological space, one where knowledge itself becomes the threat. Because here's a deeper question. If you could calculate that your risk of dying was increasing rapidly, what would you do? Change behavior? Disappear? Stop working? Keller didn't. He continued his research, which raises another uncomfortable possibility. What if the thing that killed him wasn't an external threat at all? What if it was stress? Chronic stress increases cortisol. Cortisol affects judgment, balance, reaction time. It increases accident risk. In that case, Keller's prediction becomes self-fulfilling, not because he caused his death intentionally, but because awareness of risk can change behavior in subtle, harmful ways. This phenomenon has a name: risk compensation. When people perceive increased danger, they sometimes subconsciously alter behavior in ways that increase other risks. Think about anti-lock brakes. Drivers feel safer, so they drive faster. Knowledge doesn't always protect us. Sometimes it shifts danger elsewhere. But there's another layer. After Keller's death, several colleagues reported that his final paper draft, referenced in his emails, was missing from his computer. Backups were incomplete. Hard drives had been wiped. Again, this could be coincidence. Data loss happens all the time. But pattern recognition doesn't care about comfort. It cares about frequency. And coincidence becomes suspicious when it repeats. The authorities ruled out foul play. Case closed. But Keller's emails remained, and they circulated quietly among academics as a kind of cautionary tale, not about murder, but about awareness. Because Keller didn't claim certainty, he claimed elevated probability. Which brings us to the core question of this entire story. Is knowing your risk helpful or harmful? Imagine a device that could tell you with statistical accuracy that your likelihood of dying in the next year had doubled. Would you want to know? Some people say yes, knowledge is power. Others say no, knowledge is anxiety. But Keller's story suggests a third option. Knowledge is responsibility. Once you see patterns, you can't unsee them. And sometimes patterns implicate systems far larger than individuals, systems that don't like being examined. Now, here's where we need to slow down, because stories like this invite a temptation to jump to conspiracy. But Vsauce isn't about that. It's about curiosity with restraint. So let's ask the most honest question possible. What is the simplest explanation? One answer is that Keller was under extreme stress, misjudged his personal risk, and died in a tragic accident. Another answer is that his research intersected with powerful interests, increasing his vulnerability in ways he could statistically sense but not prove. Both are plausible, and that ambiguity is the point, because science doesn't give us certainty, it gives us confidence intervals, and Keller lived and died inside one. Today, his case is rarely mentioned outside niche academic discussions. No documentaries, no official investigations reopened. Just a few emails, and a man who believed math could warn him. Which leads to one final question.